So in this first video, we're going to talk about how to evaluate logarithms, and there are a couple different ways you can think about it. One way you could do it is to visualize what the bases are and actually evaluate without a calculator using the different properties of exponents that you know, which I will demonstrate on the first two here. But then there's instances like this last one where that is not something that we would be able to do, and so we'll actually use a calculator to evaluate that. The first thing I need to remind everybody is remember when you have a square root that can be written as an exponent. So a square root of e, so this is a kind of set of note cards that I have with just some simple conversions. So if you have a square root of something, the base of the exponent, of that rational exponent, would be whatever's on the root. So we call this the index, and the index of the root would be the denominator of that exponent. So with that in mind, we can think of this as ln of 1 over e to the 1/2. And then using our properties of exponents, we can move that up. So we would have ln of e to the negative 1/2. Well, we know the base of an ln is a base e. So when the base of the logarithm and the base of the exponent are the same, those actually just cancel out. So this would just leave you with a negative 1/2 as your final answer. So likewise, over here we have a 4. Now we don't have to go through all this process because we don't have a fraction to deal with and we don't have roots. So we're going to think of this in a little bit different manner. So a logarithm is what is the inverse of an exponential equation. So we're going to visualize this according to how you might rearrange it based on those conversions that we did way back when. So here's kind of our conversion formula, and I've put these on the Google Classroom for the classes that need this. So if I have this logarithm right here, I could rewrite it as this exponent. So if you notice, we're doing the base of the logarithm is the base of the exponent. So the base of the logarithm, base of the exponent to some power gives us what's inside that log, that y. So using that idea, we can look at this and say, okay, 4, let's change this up. 4 to some power gives us 2. Well, to take a integer like 4 and actually make it smaller, but not make it a fraction, we're going to actually start thinking about the idea of the root. So ignoring the fact that it's an exponent right now, how can I get from 4 to 2 by either using a power or a root? I know that the square root of 4 is 2. And remember, a square root is the same thing as a 1/2 power. So that makes this x, because I want to square root the 4, so that makes x 1/2. So the answer to this one would just be 1/2. And like I said, I'm going to show you why this one on this third one doesn't really work. The base of this is an e. So we're really asking e to what power gives us 225. Well, e is an irrational number, and so that is not something that we can brain our way through. So we would not think of it in this method. We would actually just go through and type this straight in to our calculator. So with our calculator here, we would just type in ln, let's clear that, ln of 225. And we actually get this, and we're going to round to 4 decimal points. So this would be 5.4161. And that right there would be our answer. So the question some people may be asking is, well, that's great, but how does that work if there's an actual base? Because ln has a button, but what if I have a base and I do something like this? Well, there's 2 different ways to do it. We have a property called the change of base property. Our change of base property allows us that if I have a log a with a base c, I could do log a divided by log c, or ln of a divided by ln of c. And that's great. So we could do that, which here would put us, I'm going to separate these, would put this as log 21 over log 2. And you would just do that on the calculator. So log 21 divided by log 2. You would end up with 4.3923. The nice thing about the TI-84 Plus calculators is they actually allow you to do this. The older calculators do not. So if we go alpha window, we can see our fifth one down is a log base. So if we go down to 5, our base of this was a 2, and what's inside it was a 21. And notice we get the exact same answer. So 2 different ways to do the exact same problem. But that is how we evaluate logarithms in the easiest way. In the next one, we're going to talk about using the properties of logs to expand and condense.